Okay, so when you're thinking about electrons moving throughout the circuit, one analogy or idea that might help you with that is looking at or thinking of electrons moving as if it's water flowing through a pipe. So there's a few factors that can change how well water is moving through a pipe. So for example, if you have a wide opening, you can have a lot more water moving through in comparison to a smaller opening. So the same thing can be thought of when you're doing a wire. Thick wires have different resistance than thin wires. Long wires have different resistance than short wires. So we're going to look at all of the different factors, but I sometimes find maybe thinking of electrons in a wire the same way as water traveling in a pipe might help you with understanding what's happening here. Okay, so one factor that can affect resistance is the type of material, which we've already talked about. So most metals are very good materials for making wires out of. However, like I mentioned before, different metals have different resistance values. So actually, out of all the metals that exist, silver has the lowest resistance. Electrons can flow through it the easiest. Okay, but however, of course, silver is a very expensive metal, right? Usually silver is used in maybe special cutlery or dishes, jewelry, right? It's very expensive. So you're not going to use that for a wire to plug in your fridge, right? So the next best thing that's still relatively cheaper is copper. So most of the wires that are used in, everyday things that you plug in are copper wires. Okay, but just so you know, metals are all different from one another, like we had discussed earlier. Another factor that affects resistance is temperature. So temperature actually can affect how easily a substance can flow through. Now, a lot of people think that temperature, an increase in temperature actually lowers resistance. It's the opposite. A colder wire has less resistance. So you have to imagine, right? So here we have two wires, okay? And remember, there are atoms that make up this wire. So let's say we have a copper wire, so we have copper atoms, right? So same thing, copper wire, copper atoms, okay? Let's say we're going to warm this wire up. What happens is the particles inside of the wire start moving more, right? So we know particles are always in motion. But if you increase the temperature of particles, the particles will be moving more. So what happens here is if I'm a little electron and I'm trying to make my way through this, it's going to be difficult for the electron to move through because the particles will be continuously bouncing and kind of blocking their pathways. If you have a colder wire, these particles are not moving around as much, so the electrons won't be blocked by anything as much, right? So, of course, there's still going to be particles moving, but they're not moving as much. So colder wires actually allow electrons to travel a lot easier. This is why, remember we were talking about how sometimes electronics can become overheated. If your electronics are too hot, they actually will not perform as well. The electrons are not flowing as easily. Maybe you've experienced this. If you have your phone and you're outside on a hot day, it actually will probably work or seem to be more slow than it is if you're trying to charge it on a cooler day. So in general, like the general trend is the cooler the wire, the easier electrons flow. So there's less resistance. Okay. So another factor is the length of the wire. So longer wires have more resistance. Just think about it as how long does that electron have to travel? If it's traveling a further distance, it's going to have more resistance than if it has a small distance to travel. So if you had a wire that was double the length of another, it would have twice as much resistance. Like it's relative to the length at which you have. So if you have a circuit with all short wires, your electrons are actually flowing a lot easier than if you have a circuit with very long wires in it. Okay, and the last factor here is the the thickness of the wire. So again, think of the water going in a pipeway. So the thicker the wire, the less resistance that the electrons have. So think about it. More electrons are able to flow through that wire if there's more space that it's able to move. So if you have a very thin wire, you have more resistance because the electrons are going to have a harder time traveling through it. Okay, so here's a nice kind of summary. If you'd like to pause the video and read through this, but basically it goes over length, thickness, temperature, and material. So the longer the wire, the more resistance. The thinner the wire, the more resistance. The hotter the temperature, the more resistance. And of course, the worse of a conductor that it is, the more resistance you'll have. And then vice versa for low resistance. All right, so the next portion here is we're looking at our first mathematical formula in electricity here. So this is something called Ohm's law. So this is a way of showing the relationship between voltage, current, and resistance. So the three things that we just learned about, how they're all interconnected together. Okay, but before we're going to go into that, I want to talk about what these symbols are representing. So the formula is this: V is equal to I times R. V is the voltage and the unit is volts. I is a symbol representing current and the unit is amps or amperes. And R is representing resistance and the unit is ohms. Okay, so the formula is this. The most confusing thing I think that students come across is they get confused that V is voltage and R is resistance. That's easier to remember. Current, it's kind of weird that it has a symbol I instead of C, right? Everyone wants to think that it's a C. But just so you know, I is current. Okay, now, so normally in a question, you're solving for one of these three things. So you're either solving for voltage, or you're solving for current, or you're solving for resistance. So you can rearrange this formula to solve for any of those. So voltage is I times R, R is V over I, and I is V over R. Okay, so a handy way to remember these, okay, which I don't typically give this to my students, okay, but because we're kind of in this situation where we don't have a ton of time to go over this in depth, I'm going to kind of give this to you, but keep in mind you also write this down in your notes so you have them handy. So here you have a formula triangle. So if you take out the V, right? So V is equal to I times R. If you're looking for R, it's V over I. If you're looking for I, it's V over R. Okay? But the units are important. It's either voltage, amps, or ohms. Okay? So we're going to look at some examples. And we're going to go over how to solve for problem solving properly using GRASP. Okay, so let me get this ready to go here. All right, so let's look at our first example. A current of 4.0 amps flows through a 40 ohm resistor in a circuit. What is the voltage? So we're going to use, anytime we're doing problem solving using math, we are going to use a format called GRASP. We're going to go over this. So I put G and R together. I'll tell you what this represents. G is writing down everything that is given in the question, And R is writing down what is required. Okay, we're going to use symbols for that. So we're told here the current is 4.0 amps. So remember, the symbol for current is capital letter I. So we're told we have from the question 4.0 amps. We also know that there is a 40 ohm resistor. So remember, the unit of ohms is resistance. So we have those two things. And we're solving for voltage. So you always want to write down what is given and then what are we looking for. So I put A and S together also. So A represents analysis. So that means you're going to write down the formula that we're going to use to solve this. So we're looking for V. V is equal to I times R. Okay. S stands for solve. So what we're going to do is we are going to plug in our numbers. So V is equal to 4.0 amps times 40 ohms. Okay, so we have 4.0 times 40. So you will need a calculator actually even for next week. For the rest of this electricity unit, we will be doing calculations. So 4.0 times 40, we have 160 volts. Okay. P is basically a paraphrase. So we can say the voltage of the resistor is 160 volts. So you're just writing a paraphrase or a therefore statement. Okay, let's look at another example. A 50-volt battery generates a current going through a 10-ohm resistor. How much current does the battery generate? Okay, so we're going to use grasp. So G and R, given. So we have the volts, 50 volts. If you're not sure what the number is that they're giving you, always look at the unit. 50 volts, our resistance is 10 ohms. We are looking for current, right? All right. So our formula for current is V over R. So current is equal to V over R, and we're going to plug in and solve. So this is going to be 50 volts over 10 ohms. So 50 divided by 10 is 5, and the unit is amps. So for our paraphrase, right, we can say the battery generates, I'm running out of space here, generates 5 amps. Okay, we'll do one more example together, and then you'll practice some questions when you're doing your homework for this week. So if you look at the next thing that's assigned. All right, so we have the refrigerators connected to a 240 volt outlet. Let's start by writing the given. So the voltage is 240 volts. If the current in the fridge or on the fridge is 20 amps, so we have current, what is the resistance? So we're looking for the resistance. So let's look at the formula. So resistance is equal to V over I. Okay, we're going to plug in those numbers. So you will always have 3 out of the 4 things, right? So you're only ever solving for one thing. So 240 volts divided by 20 amps is 12 ohms. Remember the unit. So our paraphrase, the fridge has a resistance of 12 ohms. Okay, so that's Ohm's law. So the original formula is V is equal to I times R. But remember, you could be solving for any of those variables. You'll always have enough information from the question to solve for what you are looking for.